Hello, science students. Mr. Zana here. Continuing Unit 5, investigating the Earth, Sun, and Moon. Today, we are going to be learning about the Earth's position to the Sun and how it creates seasons and the lengths of our days and nights. How are we going to do this? Well, we're going to use our ISN and complete a worksheet to reinforce the lesson in addition to this Ed puzzle. This is going to help us understand why we have seasons and different lengths of daylight depending on the time of year. It will also reinforce our understanding of rotation and revolution. So if you look here in our unit organizer, we're on day 2 in the unit, and we are dealing with seasons and daylight or nighttime, all right? By the time you finish this lesson, you should be able to fill this section out down here that says Earth's revolution causes what and takes what, and then Earth's rotation causes and takes. All right. Remember to keep up with your unit organizer during the unit so that you're not having to deal with catching up with it right before the exam. So our chants today: in person, voices should be off while the presentation is going and low while you're working in small groups. Raise your hand for help. We're dealing with seasons and day and night hours. Please stay seated, or you can stand if you're having trouble staying awake. And then you're going to be responsible for answering any questions that I might have as we go through the material and be involved with the discussion. And if you do all that, we will be successful. So here we go, seasons. Can you name the 4 seasons? All right, here are the 4 seasons in relation to the sun. So the sun is here in the middle, and depending on where we are in our revolution around the sun during our year, you're going to have your 4 seasons. So you have position 1, 2, 3, and 4. So in which position is the Earth in when we experience spring? So which one of these 4 positions are we experiencing spring in the Northern Hemisphere? 1, 2, 3, or 4? All right, the Earth is tilted on its axis at an angle of 23.5 degrees, okay? This contributes to why we have seasons. So when the Earth's northern hemisphere, where we live, is tilted away from the sun, here's the sun, it causes the sun's rays to be more indirect. So they're kind of glancing off of the northern hemisphere. So that's why it's not as warm, okay? So, question being, which point would be experiencing winter in this diagram? Okay, which one would it be Y or X? Y or X? When the northern hemisphere is tilted towards the sun's light is striking the northern hemisphere more directly, so it's warmer. So it's got a real direct path to us, so that more of that sun's heat is absorbed through our atmosphere and onto the planet, so it's warmer. So that's when we have summer, right? I'm going to watch a little video real quick.
Winter, spring, summer, fall. Seasons. I just love them all. Other than inspiring me to make up goofy poetry, why wouldn't you love the seasons? There's always something to look forward to. You already know that summer means long days of fun in the sun, and winter means shorter days, not to mention building snowmen and making lots of Frozen references. Okay, so clearly the sun and seasons are linked. But how? You already know that the sun is pretty important. It is the center of the solar system, after all. You also know that our planet Earth revolves around the sun, making its orbit once every 365 days. And remember, Earth isn't taking that lap while it's standing straight up and down. Instead, it's tilted on its axis, the invisible line around which our planet spins. Put together, the Earth's tilt on its axis and the orbit it makes around the sun, and you get the yearly pattern we call seasons. Let's see how. Since the Earth is tilted, for part of the year, one of the hemispheres, which is half of the Earth, is leaning toward the sun, and the other part of the year, it's leaning away. Let's follow the northern hemisphere once around the sun to see how this works. In June, the northern hemisphere is tilted towards the sun. This means that it's getting a lot of direct sunlight, light that's hitting it straight on. If you've ever sat directly underneath a bulb, you know that things can get pretty hot, and that's exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. In December, though, the northern hemisphere is tilted away from the sun. It's getting indirect sunlight, meaning light is hitting it at an angle. Indirect sunlight means cooler temperatures, shorter days, and, for lots of folks, hot cocoa and bundling up since it's winter. But how can the angle of the sun's light make a difference between hot and cold? Well, try this little trick with a flashlight. Get a flashlight and dim the lights in your room a little bit. If you turn the flashlight on and point it straight down onto your desk, you'll see a small, bright, concentrated circle of light. That's kind of how sunlight hits the northern hemisphere during the summer. Bright and intense. Now move the flashlight down at an angle and point it at the top of your desk. See how the light isn't as bright and is less intense where it falls? That's like the sunlight you get in winter. But what about spring and autumn? During these two seasons, the Earth's orbit causes the northern hemisphere to be neither tilted toward the sun nor away from it. So temperatures during the spring and fall are more moderate, not too hot and not too cold, since the entire globe is getting about the same amount of direct sunlight at once. Now, let's take a look at how the amount of sunlight affects temperatures in the northern hemisphere over the course of a whole year. An easy way to show this yearly pattern is by using a graph. This graph shows the average high temperature in each month for 1 year in Toronto, Canada, where I live. Looking at the graph, we see that during December, January, and February, when the northern hemisphere is getting very little direct sunlight, temperatures are low. And in the months of June, July, and August, when the tilt of the Earth on its axis is causing Toronto to get direct sunlight, the temperatures are much higher. Proof positive that something is going on here, and that something is this. The season that you're experiencing right this very minute is caused in part by the amount of direct sunlight you're getting. So, seasons are caused by the Earth's tilt on its axis as it cruises around the sun in its orbit. When one hemisphere gets more direct sunlight, it's summer there. Temperatures are warmer, days are longer, and nights are shorter. And when it gets more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, and nights are longer. And now you know what causes summer, spring, autumn, and winter.
All right, I hope you guys liked that little video. It explains the seasons very well. Let's move on to our daylight hours. Daylight hours are also affected by the Earth's tilt on its axis. So when the northern hemisphere is tilted away from the sun, the length of day hours is shorter than during summer hours when it's tilted towards. Because again, you're having that indirect sunlight, and as it's rotating around and turning this way for our day, it's rotating on its axis, you're getting less sun because it's indirect, and then because of the angle of the tilt, you're getting the sun at a lower point, so as it rotates around, it's going to disappear quicker over the horizon. All right? So, daylight hours. Which point will have more daylight hours, X or Y? Which point has more daylight hours, X or Y? All right, open your ISN so that we can take some notes. We would have done this in class. We have our rotate versus revolve, and we learned this in our first lesson of Unit 5, is that the Earth rotates on its axis or spins on its axis. One rotation is 24 hours or 1 day, and it causes day and night. Whereas revolutions, the planet revolves around the sun, takes 365 days approximately. We're not going to talk about leap years. And so it takes 1 year to go around, and it gives us our 4 seasons. Now that we know what causes seasons, please complete the sentence below as to why our seasons occur. This is going to be in your ISN. This is something that we should have already done in class. If you haven't done it yet, make sure that you get this done. So the STEM sentences, the seasons are created when the blank is blank or further away from the blank. So what did we just discuss? Look at what we discussed and make sure that you're able to answer that question, okay? So now, the last thing we're going to do is we have small group time. So in class, you should have done this. This is not going to have but maybe one question here at the end of it for the Ed puzzle. But in class, you should have done your warm-up. And if you missed one question, if you missed both questions, you will take stage 1 worksheet. If you missed one question, you will use the stage 2 worksheet. And if you got both questions correct, you will use stage 3. So if you missed 2, you do 1, missed 1, you do 2, missed none, you do 3. All right? And the worksheets are right here as well for you to work on. Okay? So with that being said, good luck on your worksheets, and we'll see you next time.